My name is Mike Tunnicliffe, and I'm a developer at IBM. And I sometimes work on the SDK, both Node SDKs, and in the past I've worked on Java. And today I'm going to show you how to create an add-on for Node.js and use some VA APIs to get some profiling information out. It's only 20 minutes, and I'm going to start from the example add-on that's on the Node.js website and just code it all up. So it's going to be quite a fast and quick introduction. And if you want to go into any more detail and talk to me later, I'm happy to talk to you and hear about what sort of stuff you're working on. Okay, so to start, we're going to need to look at the documentation. So this page on nodejs.org, in the API section, you can go down to the add-ons, and it's got a little introduction about what an add-on is. And it's got a nice example. And this example comes with two files. It comes with a C++ file, and it comes with a little build file called binding.gyp. It's very short. A lot of the defaults are pulled in from the Node SDK. So if we start with those examples, which I have already downloaded. You can't break this early on. I named it wrong. It's fine. Everything's fine. Here we go. We've got binding.gyp and we've got hello.cc. First thing I'm going to do is I'm going to change the name of hello.cc because we want to make something that prints a profile out. So I'm just going to rename that. So we need to update our build definitions so that it's going to see that rename. And when we do our build, it's going to produce a .node file, which you can require just like a normal JavaScript module. And the name of that will come from what we put in this field here. So I'm just going to call it the same thing, print profile. And now inside our C++, well, we're not hello.cc anymore. We've got a little bit of code I'm going to explain in a little bit. But the most important piece is this bit at the bottom here. And we get some macros that get pulled in by node.h, which tell Node what our add-on, a little bit of information about our add-on. So here we've got add-on, which is the name, and that's got to match what we put in our binding.gyp. So we're going to change that to print profile. And then we've got to define the entry point to our add-on, and that's in it, and we'll just leave that as it is. So I'm going to try and compile this a few times, probably about 3 times if everything goes well during the presentation. If it goes well, I'm going to cheer. If it goes badly, you can cheer. We'll see what happens. You'll also need to install something. You need to install with npm the Node.gyp module so that you can do the native compilation. I've already done that, so that's what you need to run to do it. Let's try and build it. So we need to pass, the first time we build our add-on, we need to pass configure, because that's going to tell it to set up our build environment. And then we need to tell it to build our add-on. Yay, it worked. Okay. So just to test this out, I'm going to start the REPL. Actually, first, I'm going to show you what it created. It created a build directory here for our configure, and inside that, we can see it's produced a whole bunch of files. A lot of these files are like intermediary files. Some of them were produced by the configure step, and some of them are just like object files created while we built. But the one we're interested in here is the printprofile.node, and that's our add-on. And it's put it in the build release directory because we do release build by default. If you pass -debug, then it will produce a build debug, and it'll have debug symbols and things. So I'm going to copy that so that I can now do a require. I'm going to require this directly, but if you put it in your search path for modules, then you can just put print profile in, and it's fine. You don't need the .node on the end, because it will sort things out for you. And we'll get back an object that looks very much like a JavaScript module would give you. And if we call the hello function, we're going to get world back, because that's what the example plugin does. It just creates a JavaScript string world and returns it back to the hello function. Okay, next step. We want to start the profiler. So what I'm going to do is I'm going to change the definition here in this init, where we've got node set method. This is another macro that's come in from node.h, and it will allow you to bind the JavaScript method to a native C++ function. And here I'm going to just use start profiler as the name on the JavaScript side. And here I'm going to change method to start and change this corresponding method name up here, or function name. So what this was doing before is the first line here inside this function was going to get an isolate. It's going to get the current isolate. For Node, this means it's going to get a kind of a handle to the V8 runtime that Node is using. And we can then pass that into the API to get all the sorts of things out that we need. The second line here is creating a handle scope. And the handle scope is like a little container for all the references you have to objects on the JavaScript heap. And so at the end of this function, that's going to go out of scope, and it's going to run the destructor, and it's going to do some cleanup for us. And here, what we've got passed in is an args value, which is a wrapper around the arguments and return value for the JavaScript side of this function. So originally, we were returning a value, but in this new function, we're not going to. But what it was doing was looking in the args to get an object that represents the return value and setting it to this string. And here we're creating a JavaScript string using the API, the V8 API, passing in that isolate that we need, and just a C string. Say we're going to create a JavaScript string which has that value. And I'm going to keep that bit because we're going to need that. But we're not going to return a value from this function. So at this point, I just want to come out here, and if it's all set up properly, oh no, it's not quite. I'll show you the headers. These headers are available inside the Node SDK. On Windows, you have to download them separately, but on Linux, we have them right here. This is the v8.h, which is the V8 API, essentially. It's most of it anyway, it's all the main parts. I've gone down to the bit because it's a really large file, which is inside the isolate definition of that class, and we've got the getCPU profiler function, which is the one we want to call. In fact, I'm going to copy that out and paste it in here. And we need to call this on the isolate object. Now we've got an instance of our profiler. The rest of the information about the profile is actually in a separate header file. And we're going to have to include this, so don't let me forget, because I always do. In here we have the CPU profiler object. I'm sorry, it's all a bit scrunched in. And you can see there's some methods on here. Set the sampling interval. This defaults to 1 millisecond, but you can change it to something else. And what that's going to do is every millisecond, it's going to stop the node main thread, and it's going to look at the stack, and it's going to send that over to another thread on a wait-free queue. So it's only going to delay the application the minimal amount required to take the sample. And it does that every millisecond. And then the API is going to provide us a tree which shows us all the nodes and what number of samples they've accrued in the period of time the profiler was running. So we just want to begin with, just run this start profiling function. So we're going to run that on the profiler here. That's where I need to be very careful to spell everything correctly. And we want to pass in a title, so that's where I'm going to use this string creation function, because it needs a JavaScript string. Okay, so that should be good, and we're ready for our second attempt to compile, apart from, no one reminded, well done, you reminded me, thank you. We need to include the header. Oh, that's a narrow escape there. So we're going to build it again. Yay, it compiled again. So what I'm going to do here is I'm going to run a little script that I wrote. So start a REPL, and this script's just going to watch the threads of this node instance so we can see what threads are running. So it's found the instance and showing 3 threads. So normally you think of Node as being single-threaded, and it is for JavaScript, which will run on that top Node thread. But there are also some other support threads that are going to be doing some things. So this one's related to the compiler and optimizing code, and this one's related to the garbage collector. So what I want to do here is the same as I did before. I want to require wherever it was. This. And now we should have start profiler. And what we see in here is that we get an extra thread. This is a thread which is receiving all of those bits of sample data from the sampling every 1 millisecond, and it's going to process those and make sure that it keeps everything in sync, because if something recompiles, it might move in memory, and we need to retain the mapping of that function to its address, so we can then find out what the stacks are and resolve all the symbols. So the final part is to actually print out the results of that process. So let's take a copy of this start function, make a stop function. So it's going to have pretty much the same signature as the start profiling, but it's going to return this CPU profile object. And we should want to check that that actually returned a value. And then we're going to create a method to print that profile out. I'm just going to do that from C code. Now I'm going to pass well, I'm not going to pass the profile, I need to fix this. Okay. I'm also going to pass 0 in here, and we'll see why in a second. And once we've done the printout, we want to probably delete the profile, so we don't have a memory leak. So what we want to put in here, it depends what's inside this CPU profile. See if we can find it. Okay, here's the definition of the CPU profile object. So we get the title that we put in. We get this top-down root. Now this is a tree that represents our sample data. So each node is going to represent a frame on our stack. And these are kind of munched together of all of the samples we've taken. So they will also have a number for each of those nodes, which represents the number of times that function has been at the top of the stack and was actually running. But every other function will also be in the tree. For a particular sample, only the top one will have one number, maybe. And each time it runs, it's going to accrue one more, so you get a count of the samples. And all of the other parts of the stack are going to be the parents of it. So you can always look at one particular node, trace its parents, and reconstruct the stack that was running at the time. So what we need is this. So that's what we want to pass through and print. Here we go. So let's define that function. Going to get this return type here. That'll be our node, and then we'll just have an integer. And this is going to be the level of indentation, because I want to indent it as we're going through the tree. Keep hitting page down by mistake. There we go. So what we have here is a CPU profile node. And inside that node is going to be all that good information that we want. So the function name, that's a good one. Probably want to print that out. Let's take a copy of that. We've got the script resource name, so that's a script that function came from. Let's print that one out as well. And we probably just want to know the number of samples there are, which is this one, get hit count. Okay, so this is giving us back a JavaScript string, but we need to convert that to something that C can print. And there's a couple of ways you can do this. String has a write UTF-8 function, which if you give it a char star or an array of characters, it will write that name into it. But there's also a helper class to do this, called UTF-8 value. And if you dereference the value of that, then it will give you back a char star, which we can print. So let's do that with a function. And now you also need to remind me not to forget to dereference it, because I might do that too. Let's take a copy of that. And the other thing I always forget to do is these are actually off the node, so we need to call it from the node object. There we go. And this is just an integer, so we can just put that into hits. So now we have everything we need to print out a simple profile. So let's use the standard library to do that. We want to have an indent though, so let's create a string using the fill constructor, where we can just pass in a number and a character we want to have that many times in the string. And we'll use that as our indent. And we want to have the script name, dereference it, and a space, and then the function name that we're calling. And then just a new line. And the final thing to do is, because this is a tree, obviously we need to go through all the children. So we just have a little simple loop. And the node has a get children count. I think that's what it's called. Yes, get children count. So we're simply just going to call our print profile function on the children. Oh, yeah, node get child. And pass in the index. And then we'll just pass in the level +1 to get a level extra of indent. Now, the only thing we need to do now is include the STL, the IOStream library, so we can do the printing out. And we should be done. Amazing. If that never happens, I always make a mistake. Okay, so let's try that out. I actually have a script to try this out with. So this is just going to require our module. It's going to define this function crunch, which is going to do a lot of JSON stringifying, just to put some processing in. Then we'll start the profile with our module, do the crunching, stop the profile, and hopefully we'll see that the crunch function will be accruing a lot of samples. So the profiler is statistically based. It's not going to measure the time something has taken, but it's going to tell you of the times that we looked, this is what was running. I forgot something. I know what I forgot. It's not a real demo if you don't forget to do something. So we needed to add the binding for that function. Okay, let's try building it again. Good. 4 times building. That's not bad. There we go. We get a little tree out. There's not a lot going on in this little script, so there's a very simple tree. You can see the stack of the crunch function here, and that's accrued 312 samples. You can see, because the profile is running every every millisecond, it's producing a lot of samples, so you can get a lot of detailed information here. And there were 3 samples just spent in the script itself, probably starting the profiler and stopping it. And you also have got information about, well, we did some garbage collection, and the garbage collector took a little bit of time as well. Okay, that's everything I wanted to show you. thank you very much for listening.